Hello everyone, welcome to my YouTube channel and to what will hopefully be a series of videos about game development. Who am I, you might ask? I'm just a guy who likes to make games. You can call me Lentor, and today I want to talk about inventory systems. So if you've spent enough time in game development, you've probably wanted to develop an inventory system at some point. And I know what you're thinking. There are already plenty of tutorials on how to do this in Unity. So why do we need another? Well, to be frank, I have a few issues with a lot of the tutorials that I've found regarding inventory systems. So I'd like to propose a different approach to solving the problem. We will be digging into code in this video, but I first want to talk about inventory systems from a bit of a philosophical perspective. Let's start with a simple question. What do the inventory systems of all these games have in common? They are all containers of stuff. Now, I know that sounds really obvious, but hear me out. A lot of tutorials dive straight into the specifics of the inventory system. Item slot stacking, scriptable objects, inventory limits, singletons, and just... Okay, let's take a step back for a moment. What do we want? Remember the three games with inventory systems. They are all just a container of stuff. So let's make just that. For context, we will be building a base for the inventory system using Unity, but what I will be explaining are concepts that translate to other game engines as well. First, let's start with just the item class. For simplicity, we're just going to define an item with a name, an item type enum that we'll define shortly, and an icon for display. We'll add a constructor for the item to set the variables and add properties to the class. Let's also be sure to define our item type enum. Pretty simple, right? That's how we want it. Next is the inventory class. We may modify it later, but for now, let's start with an iCollection property. A constructor. And an add method that will add items to the list. That's all I need for now. The reason we are going with the iCollection is in case we want to create a child class of this in the future. We'll also do a fancy little trick and make our inventory implement the IEnumerable interface and implement its methods. What this will do is allow us to use the for each keyword to traverse our inventory without needing to access our iCollection directly. This is great because now the traversal of items in our inventory is encapsulated, which means outside classes won't know anything about how our collection of items is implemented. Don't worry, we don't have to do anything scary with these methods. We'll just make the getEnumerator method return our items enumerator by calling its getEnumerator method, since iCollections also implement the IEnumerable interface as well. This may seem a little complicated, but don't worry. The simple reason for this is to allow us to use for each on this inventory object. If you're interested in diving deeper into enumerables and the iterator pattern, let me know in the comment section. If there's enough interest, I'll do a video on it. Now that we've done all that, let's just run a quick test. To do this, we'll write up a quick inventory test script. In our test script, we'll just add a bunch of serialized fields for each item to set the data for our three items. We'll also set up a private variable for our inventory object. In the start method, we'll instantiate three items separately using our serialized fields. Instantiate the inventory object. And then write a quick for loop that just prints the name of each of the items. Remember how I said the IEnumerable would come in handy? I can just use for each on this inventory, and it just works. See? No errors. Over in Unity, let's create an empty game object called inventory test and add the inventory test component to the object. We'll add a sprite for each of the items, give them names, and then make sure to set their item types appropriately. Now, if we hit play, we should get the names of each items in the log, and we do. This works nicely, but I highly doubt you'd want to hardcode the items the way we do in our test script. It would be better if we could persist data about our items instead. This way, we'd be able to use them as we need them. Now this is where scriptable objects come in handy. Before we jump right into using scriptable objects, I just want to point out that our inventory system knows absolutely nothing about scriptable objects. More precisely, it knows nothing about how the item data is passed to it. Technically, to do what we want to do here, we don't need to use scriptable objects. We could load a JSON file with all of our item data and then pass newly instantiated items from that JSON data to the inventory to be added. Or you could use a simple text file to store the data. Heck, if you really wanted to go crazy, you could use a SQL database for all your items. Not really sure why you'd do that, but you could, and our inventory system would be none the wiser. The point I'm making is that it's important to separate the responsibilities of all the parts of your game, so that each part only knows about what it needs to know, and other parts only provide details about themselves that should be known by others. Alright, enough of that. Let's write up this scriptable object. I'll start by creating an item data class that will inherit from scriptable object. I'll add the create asset menu attribute to it, and then give it the public variables it needs to represent an item. That's it. Very simple. Now let's create a class called itemGameObject and have this one inherit from AutoBehavior. This is just going to be for the game object in our scene that the player will be able to pick up. We'll give it an item data instance variable, and we'll use the serialized field attribute so that we can drag and drop our scriptable objects into it. In Awake, we'll quickly set the game object sprite to the item data's icon for now. Then we'll set up an onTriggerEnterToD method that waits for the collision with the player, and if it collides, I'll call the player's addItem method. Passing in an item we instantiated using the item data into its parameters, and then deactivate the itemGameObject. We'll hop into Unity and create a few item data assets. Then we'll create a few empty game objects in the hierarchy and add a sprite renderer, a box collider 2D or regular box collider if you're making a 3D game, and the itemGameObject script we just created. Also, be sure to set that box collider's isTrigger field to true. I've set up a player object already with some input to move around and a reference to its own inventory object so that the player can add items to the inventory. If we run this, we'll be able to walk over an item and it will automatically pick it up. When I press the tab key, it will print a log in the console of each of my items. And that's pretty much the basis of our inventory system. Now, I know we haven't built a real UI for this yet, but I wanted to start with regular Unity debug logs so that you could see that you can build your inventory system without caring about how the inventory is represented in your game. We'll cover how to hook up some UI to your inventory in the next video, so subscribe to the channel if you'd like to see how that works. See you soon, and good luck!